Bronchitis is a respiratory condition characterized by the inflammation of the bronchial tubes, which carry air to and from the lungs. Bronchitis is caused by a viral or bacterial infection, but it can also result from exposure to irritants like tobacco smoke, dust, fumes, vapors, and air pollution. Symptoms of bronchitis include a persistent cough that produces mucus, wheezing, chest discomfort, fatigue, fever, and chills, which may last for several weeks or longer. Treatment for bronchitis includes rest, increased fluid intake, using a humidifier, and taking over-the-counter cough suppressants and pain relievers. In cases of bacterial bronchitis, antibiotics may be prescribed. Welcome back to another episode of Paula Marie Club's Ask Dr. Paul. Today we're going to highlight the thermoplastic processing technique, rotational molding. So when your boss talks about large, sealed, and hollow parts that are formed by mold rotations, what do you need to know? Rotational molding, also known as rotomolding, is a unique process that involves a heated hollow mold which is filled with plastic powder. The rotomolding machine is slowly rotated, usually around two perpendicular axes or biaxially, causing the softened material to disperse and stick to the walls of the mold. To maintain an even part thickness, the mold continues to rotate at all times during the heating phase, and to avoid product sagging or deformation, it also rotates during the cooling phase. Common products made using rotational molding include tanks, containers, recreational equipment, toys, automotive parts, and high-end custom products. And don't forget pink flamingos and kayaks. The process is suited for creating hollow products with consistent wall thickness and complex shapes. The most common plastic in rotational molding is polyethylene, which accounts for more than 80% of the rotational molded products, due to its low cost and ease of molding, good chemical resistance, and low water absorption. Other materials include polypropylene, PVC, and polycarbonate. Semi-crystalline plastics are preferred over amorphous plastics in rotational molding because they have a highly ordered crystalline molecular structure with a sharp melting temperature, which is generally above the upper temperature range of amorphous thermoplastics. Semi-crystalline plastics process well since the material does not soften gradually like amorphous plastics, but transitions sharply from a solid to a molten state. It lays down well, creating better surfaces and seams. Plastic powder is preferred over plastic pellets in rotational molding because the powder melts and flows more easily, coating the mold interiors more uniformly, which results in better control of wall thickness and a higher quality finish. The powder form also facilitates the coalescence of particles during the heating phase, which is crucial for forming the seamless hollow parts characteristic of rotational molding. Lightweight medical backboards are made by rotational molding and are expected to carry 180 kgs. And to do this, powder is placed in the open mold and it is closed and heated, and the mold is rotated biaxially. Powder sticks or melts uniformly on the interior mold walls, creating a uniform walled hollow part, which is cooled with air and water and finally demolded. Lastly, the backboard is filled with polyurethane foam post-processing and is ready for service. Knowing the rotational molding process and the sealed hollow products it produces, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. You can visit our website to learn more about our upcoming polymer processing course. I'm Paul Nash for Paula Marie Club's Ask Dr. Paul. Thanks for watching.